Hi friends. Ever thought about how your phone charger gets power? Spoiler, it's probably from boiling water, yawn. But Chinese scientists said, enough. After 15 years of hard work, they invented supercritical CO₂ tech. It's like a smart juice maker for electricity, smaller, cleaner, and uses 1/3 less coal. No fancy jargon, just game-changing results. Let's check it out.
You know, for over a century, the way we've powered our world has relied on a surprisingly simple idea. It's so fundamental, in fact, that it became this common saying in the tech world. You've probably heard it before. Yeah, think about it. Nuclear reactors, coal plants, what do they really do? They use a ton of heat to boil water, create steam, and then use that steam to spin a turbine. That's been the basic playbook for power generation for, well, forever. Well, until now. That old truth, that fundamental rulebook for our entire energy system, it's just been completely torn up, all thanks to a massive breakthrough coming out of China. To really get just how huge this is, we gotta take a second to look at the reigning champ, steam power. I mean, for over 100 years, it's been the undisputed workhorse of electricity for the entire globe. And listen, we've gotten incredibly good at it. We've pushed steam to its absolute limits, going from just basic steam to these ultra-supercritical states, just trying to squeeze out every last drop of efficiency. But here's the thing, we've pretty much hit a wall. There's not much more we can get out of steam. So what's next? Well, all the world's big tech powers have been searching for an answer, and they all kind of landed on the same idea. Maybe the answer isn't water. Maybe it's a whole new type of fluid. Specifically carbon dioxide, but when it's pushed into a very, very special state. It's called a supercritical fluid. So what on earth does that actually mean? Well, if you take a substance and you crank up the heat and the pressure past a certain magic point, it enters this totally weird hybrid state. It's not really a liquid and it's not really a gas. It's kind of both at the same time. And this is exactly why it's so powerful. Supercritical CO₂ has the density of a liquid, which means it can carry a ton of energy, but it flows easily like a gas, with very low friction. It is, quite literally, the best of both worlds if your goal is to spin a turbine. Okay, so it's a cool science trick, but why is it actually better than good old water? Well, it all comes down to a few absolutely massive advantages. Let's start with the basics. In a closed system like this, CO₂ is stable, it's non-toxic. But the real magic, that comes from its potential for much higher efficiency, a way smaller physical footprint, and, this is a big one, the conditions you need to make it work are just so much easier to achieve. Just look at this efficiency gain. An sCO₂ system can be 5% more efficient than our most advanced, state-of-the-art steam system. Now, I know what you might be thinking. 5%? That's it? But you have to understand, in the world of power generation, a 5% leap isn't just big, it's a seismic shift. It's an earthquake. And to put that 5% jump into perspective, just think about this. It took us almost a full century of incredible innovation and engineering just to squeeze the last 3% of efficiency out of steam power. This new tech gives us a much bigger jump, all in one go. And here's a huge reason why it's so much more practical. Look at the conditions you need. To get water to a supercritical state, you need brutal temperatures and absolutely crushing pressures. For carbon dioxide, you only need about 31 degrees Celsius. That's basically a warm summer day, and less than 1/3 of the pressure. It's just so much less demanding. So what's the direct result of these less extreme conditions? It's staggering. The equipment, especially the turbine, can be radically smaller. We're talking about a machine that's just 1/25th the size of a steam turbine, but produces the exact same amount of power. It's just wild. So, because of these incredible benefits, developing this technology pretty much sparked a fierce, high-stakes race between the world's powers. The United States, for instance, had pinpointed this as a top priority years and years ago. In fact, the U.S. government officially called CO₂ power a game-changing technology and invested a lot of money into the research. But despite all that effort, they kept getting stuck on the final, most difficult step, figuring out how to make it commercially viable and scalable. 15 years. That is how long the Chinese research team dedicated themselves to solving this single problem. A decade and a half of just pushing through every single obstacle and engineering challenge until they finally did it. They cracked the code, achieving the world's very first commercial breakthrough. So the science is cool, the engineering is impressive, but what does this actually mean for the rest of us, for the world? Well, the answer is in some truly world-changing numbers. According to the estimates, if we took existing thermal power plants and retrofitted them with this new sCO₂ technology, their overall efficiency could jump to around 55%. That's a huge leap from the typical 38% efficiency you see in traditional plants. And here's what that actually means in the real world. For every single unit of electricity you make, you'd burn 1/3 less coal, just like that. That's a massive, massive reduction in the amount of fuel we use. Now, what if this technology were rolled out everywhere, across all existing thermal power plants? The estimated reduction in carbon dioxide emissions every year would be over 3 billion tons. That figure is just colossal. But it doesn't just cut down on waste, it also generates more power from the same resources. We're talking about an estimated gain of 1.1 trillion kilowatt hours of electricity every year. 1 trillion kilowatt hours is a number so big, it's hard to even wrap your head around it. So let's try an analogy. That amount of extra electricity is the same as building 11 brand new Three Gorges dams, one of the largest power stations on Earth, and getting all that new power every single year without building a thing. You see, this isn't just a small improvement. It's a fundamental shift in how we can generate power. It makes our existing infrastructure cleaner, more efficient, and vastly more productive. It really makes you wonder, are we standing on the edge of a completely new era for energy?